Hello and welcome to this video on reflections. In this video we'll cover performing reflections and describing reflections. So without much delay, let's go straight in. And then again, a special thanks to Corbett Maths. I'm using some of their questions in order to do these examples. So the first one, I need to reflect this rectangle in the mirror line. We can see the mirror line is there. The beauty of a mirror line is everything is the same distance from the mirror line as it is from the everything in the image. So that means the new shape is going to be the same distance from the mirror line as the original was. So if we see here, for example, we can see that this is 2 away from the mirror line, this point here. So 1, 2. So the 1, 2 from the mirror line is where that's going to end up. And likewise, this point here is going to be 1, 2, 3, 4 away. So 1, 2, 3, 4 away is going to be there. And we should be able to see now that those two can join up. And we know that the rectangle was 4 high. So I don't need to move those points because I know where they're going to be because I know enough information already to complete that. And that's all there is to it. That's my image now. Let's have a look at a triangle just to see how that works there. You can see here you might have to guess where the top is if you don't do it carefully. So let's move the top first then. So that was 3 squares away from the mirror. So 1, 2, 3 squares away from the mirror. That's where the top is. This point here was 1 square away from the mirror, look, this point. So this is 1 square away from the mirror. And then this last one was 1, 2, 3, 4, 5 away. So 1, 2, 3, 4, 5 away. And then, of course, I use a pencil and a ruler and probably a sharp pencil I probably should add so that it's accurate. Never use pen. Even if it looks like it's a 1-mark question, it's very easy. Don't use pen. The whole reason a pencil's permitted in the exam is for questions like this. Now, what do we do when it touches the mirror line, as in this example here? Now, if it touches the mirror line, that is going nowhere. Those 2 points don't go anywhere. They stay put. So it's actually only the other points that I need to deal with. So this point here is 1, 2, 3, 4 away. So 1, 2, 3, 4 away. We now know that the shape went down by 5 squares. So 1, 2, 3, 4, 5. I now know that went 2 across. So that goes 2 across, or I could have gone 2 from the mirror line, 2 from the mirror line. So let's just do what I've got so far using straight lines and ruler. Like that. Then I know that this goes up to here. If I'm not sure, let's just see. 1, 2 away, 1, 2 away. So that point goes there. And we should be able to see it. That goes to there. And then we've got there, and it looks like a letter N. What happens if the mirror line is the other direction? So let's have a look at this one. If the mirror line is this direction, doesn't change a thing, look. We're going down by 1 because it's 1 square away from the mirror line. So that's 1 square away from the mirror line. This one, 1 square away, 1 square away. Straight away, we can see that we've got the bottom, if you like, or is it the top? Because we've changed the way the shape is organised on the page now. Now we know that it was 1 square up. So 1, 2, 1, 2. So that's there. So that's going to be 1, 2. You can see from the symmetry where that's going to be. Got that there. That there. Where's this point going to be? 1, 2, 3, 4. So 1, 2, 3, 4. That point's going to be there. So we know at this point's going to be next to it. And then I think you can see that's going to be there. And then we can see that this shape will look something like this. We can see because we're using a pencil and a ruler, it's super accurate. It looks really, really nice. We're not going to lose any marks for anything being in the wrong place. So they're the pretty straightforward ones there. Let's look at what happens when we have one which has a diagonal on there. So I'm looking at something like this one here. So example 2A. So here you can see my mirror line is diagonal. So my shape is certainly not going to get reflected up there because it will go off the page. If it gets reflected over here, part of the shape is going to go over the mirror line, which probably is not going to be right because it's not touching the mirror line already, so that's not going to be right. So when we've got a diagonal mirror line, we need to reflect diagonally as well. Now, there are two ways to do this, and I will show you both ways. So the first way is where that corner is, go diagonal squares, so like corner to corner, and see how many diagonals it was. So here to here is one diagonal square, look, from one corner to the other, one diagonal. So from the mirror line, it's one diagonal away as well. Now let's look at this one diagonal away, two diagonals away. So 1, 2. So that's going to go there. And we can see now the shape's going to kind of flip sideways. Let's try this one. 1, 2, 3 diagonals. So 1, 2, 3 diagonals. And at this stage, you may be able to guess that the next point's going to be here. But let's confirm it just using the point ourselves. So 1, 2, 3, 4 diagonals. 1, 2, 3, 4 diagonals, and that will go there like that. And now I should be able to draw the shape, and we can see it's gone in almost a sideways direction. It's rotated it, if you like, but it's still a reflection. It's not quite a rotation. It just looks like a rotation. We could actually probably describe this one using a rotation if we wanted to, but we can see what's happened there. Now, I said there were two ways to do this. There is another way to do it as well. I don't like this way as much, but it's worth knowing because it can help you if you forget the other way. So I'm going to use this point first. So instead of going diagonal, go in a straight line instead. So 1, 2. But when we hit the mirror line, because it's a diagonal mirror line, we turn and we go the opposite direction. So 1, 2. So I go 1, 2, and then I'm there. Look. So let's recap that again. 1, 2. I hit the mirror line. I know the mirror line's diagonal, so I rotate my direction. And rather than going another 2 over here, I turn and I go 1, 2, and that's there. Now let's do this one. Okay. 1, 2, 3, 4. I turn 1, 2, 3, 4, and I get to there. I could have done it in the other direction as well. Look. 1, 2, 3, 4. Turn 1, 2, 3, 4. Let's just try one last one to prove it. 1, 2, 3, 4, 5, 6. Turn 1, 2, 3, 4, 5, 6, and that would work as well. Let's try this triangle because that would catch a few people out. We might not have an idea about where that's going to be. Is it going to be down here? Is it going to be here? Is it going to be directly opposite? Let us see. Let's use the diagonal method because that's my preferred one. So 1, 2 diagonals. So 1, 2 diagonals. So that point is now done. This one, 1, 2 diagonals. 1, 2 diagonals. Then the very last one is this corner. 1, 2, 3, 4 diagonals. 1, 2, 3, 4 diagonals. That's gone down the bottom there. And I draw that on like that and like that. And then I join them together and we can see that's the mirror line. We can see everything's the same distance. You can see with your eyes, really, can't you? You can see everything's the same distance from this this mirror line here, look. And the last example I'm going to do before we start to look at describing them is this one. So we can see here we've got half a square distance. Look, half a diagonal. So half a diagonal is going to be there, look. This one, 1, 2 diagonals, 1, 2 diagonals. This one, 1, 2 and a half. 1 half, 1 and a half, 2 and a half. Then this one, 1, 2, 3, 4 diagonals, 1, 2, 3, 4 diagonals. And you can see, if I'd have got one of the corners incorrect, you would have hopefully been able to see it obviously, because one of the corners would have been like floating away from the others. We've got that there. And that's our final answer for that one. Now let's look at what happens when we have to describe these now. So, no, we'll have a look on an axis first. We have a look at on an axis, and then we'll look at describing them first. So, if we look here, we've got this question on an axis. Reflect triangle A in the x-axis. So the x-axis is the one that goes across. It's normally labelled with an x as well to help us. So reflecting in the x-axis means that the shape is going to be reflected here. So this is my mirror line, if you like. The x-axis is my mirror line. So we do the same as what we've just been practicing. So 1, 2 away. So 1, 2 away. So that's going to go down the bottom there. Now this one, 1, 2 away. 1, 2 away is going to go down there. And then the last one is this point here. That was 1, 2, 3, 4 away. So 1, 2, 3, 4 away. That's gone down the bottom there. And we can see we've got the triangle perfectly aligned there. That goes there. That goes there. And then we join them up. And we can see that the reflection is down the bottom there. If it's in the y-axis, remember the y-axis is mostly labelled. It's the one that goes up. So this time we're reflecting, so it's going to be over here. So the mirror line this time is the y-axis. So 1, 2, 1, 2. That point's going to go there. 1, 2, 3, 4. 1, 2, 3, 4 is there. This one. 1, 2, 3. 1, 2, 3. And then we can see that we've got that reflected in the axis. Just make sure when you do these that you reflect in the correct axis, because you can see from this one I could have reflected in the y-axis, the x-axis as well, and my triangle would be down here, but it would be wrong. Let's have a look at in a given line now then. So let me just have a look if I've got the first ones. Yes, let's have a look at these ones. So here we go. Reflect shape A in the line x equals 1. So x equals 1. So we need to look at x equals 1 first. So we need to draw that line on there. So x-axis first. So x is the across axis. 1. So x equals 1 is there. Now the line x equals 1 is the line that passes through that point there. So it has to be the line that goes down here. It can't be the line that goes across like that, because that doesn't pass through 1 all the time. Look, it goes through all the numbers. So x equals 1 is going to be this straight line here. And I'm going to label that x equals 1 for anybody looking at my diagram. And now that's my mirror line. So I'm now reflecting in the new line which I have drawn. So this point, look, is 1 away. So 1 away, that's going to be there. This point here is 1 away. So that's going to be 1 away. And then this last point here is 1, 2, 3, 4 away. So 1, 2, 3, 4 away. And we can see now that part of that triangle actually lies on the x-axis. So we can just about see that. And then that is going to be like so. That's reflected in that line. It's not reflected in the axis this time. Let's have a look at this next one. Reflect shape B in the line y equals -2. So x equals -2. Sorry, so we're looking at x-axis, remember? -2 is here, and it's the line that passes through -2, so it's this line here. So let me draw that on there first. You must always draw it as well. Don't just say, yeah, I know where that is, I can reflect in it. You have to draw it. It's part of the question. X equals -2. I've labelled it, so I know that that is the line. Now let's reflect this. So 1, 2 away, 1, 2 away. That was there. This point, 1, 2, 3 away, 1, 2, 3 away. And we can see, I think you can probably get that point's going to be down there, and that point's going to be down there. So we don't have to do every single point. As soon as you get to a point in the question where you're comfortable, where you know that those other 2 or 3 points may be, then go ahead and complete the diagram. You don't have to move every single point, because that's learning from experience then. Let's look at a y then. A y example. So y equals -1. So y-axis. So y-axis is going to be here, look. So the y-axis, and it's y equals -1. So we're looking at y, and then -1 is there. So it has to be the line that passes through that. So it's got to be this line that goes across here. So let's have a look at what that looks like. So we're drawing that line across, and that is y equals -1. So we're reflecting this shape. So 1, 2, 3 away, 1, 2, 3 away. That's gone to there. This one, 1, 2, 3, 4, 5 away. So 1, 2, 3, 4, 5 away. And the last one, 1, 2, 3, 1, 2, 3. Notice I didn't complete the other points on this one straight away because it wasn't so obvious about where they were going to be. You might have put the point on the triangle a bit more in a the wrong place, sorry, a different place that it should have been. The rectangle was much easier for that last question, so we could complete it a bit easier. And that's going to be down the bottom there, look. Okay, now what I'm going to have a look at is we're going to have a look at describing some of these. We just need to look at the reflecting in the diagonals and then we'll look at describing them, sorry. So let's have a look at reflecting in these diagonals. So this is a diagonal one which I'm talking about here. So we need to reflect the shape in the line y equals x. So whenever you see this, y equals x, this means that the y and the x value need to be the same. So when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. And you can see if I did this little diagram or this little pattern completed, it's going to be a diagonal line. So when I draw this diagonal line, look, it's straight through the corners of all the squares, really neatly, look, through the corners of the squares. So that's the line y equals x. Y equals x. So what I need to do now is I can do the thing that I did before, reflecting in the diagonals. So half a diagonal away, half a diagonal away. 1.5, half, 1. And then this one, 1, 2.5, half, 1.5, 2.5 is going to go there. So we should be able to see that this is going to be there to there and then to there. So that's that shape reflected in the diagonal there. And you can see everything's the same distance away. It looks a bit weird when you're trying to get your head around where it's gone because it's actually moved. It's actually like spun around. So that's actually gone to there and that's actually gone to there, but you can't really see with your eyes because it just looks like, because they're both 2, we can see it's like that. Okay, next one. The line y equals minus x. So this is when the value of y is the same as the negative x. So when x is 1, y is minus 1. When x is 2, y is minus 2. When x is 3, y is minus 3. So we can see the pattern this time is going to be diagonals again, but the diagonals, if we look, are going to be going down instead, look like this. So now let's do our diagonals. So one diagonal, that's gone to there. 1, 2, 1, 2, that's gone to there. This one, so this one, 1.5, half, 1.5, and you can probably see at the last point is going to go there, and then we're going to have a shape, which is that particular rectangle lying on its side, look, like this. There we go. So let's have a look at describing them. Now we've looked at a few of those diagonal ones. Now the diagonals don't come up as often, so that's one thing that's worth mentioning. So let's have a look at these describing now. So example 7 on my sheet here are telling me about describing these transformations. So we can see they are reflections. So I'm going to use the word reflection first because I get 1 mark for that. So reflection, and then I just need to say in what line or what mirror line. In, and what's the mirror line this time? So we've gone from A to B. So we can see it's a reflection because it's not flipped, it's not got bigger or smaller, and it's certainly not rotated. So we just say, pick a point and pick the corresponding point on the new shape or between them. See how many squares it was between them? 1, 2. What's half of that? 1. So I'm going to mark that point on my mirror line. Now the next one, I'm going to pick this corner and this corner. What's the distance between them? 2. So halfway is 1. So we see these 2 points now. You only need 2 points to draw a straight line. They are the mirror line. And what is that mirror line? On this occasion, the mirror line is the x-axis. So let's recap. What did I do there and why did I do it? I know that the mirror between 2 objects, so between the original and the new, is always exactly in the middle between them. That's what we've been basing all the questions we've done so far off. That's how these are done. So to go in reverse, we're finding the middle between them, and then we put points there. We only need 2 points to do a straight line, remember. Any 2 points in the world, I can join them up and create a straight line. We can't do it with 1 point, we need 2. So this is a reflection in the x-axis. Let's look at this next one. We can see between them. So let's pick this point and this point. The distance between them is 4 squares, look. So halfway is 2. Let's pick this point at the top of the stick. The distance between them is 1, 2, 3, 4. So halfway is 2. And we can see this time the line that joins them up is the y-axis. So it is a reflection in the y-axis. So reflection in the y-axis. Let's have a look at these triangles next. Pick this point and this point. What's the distance between them? 1, 2. So halfway is 1 square. This point and this point, the distance is 1, 2. So halfway is 1. So my straight line, which is going to be my mirror line, let's join these together, is not the x or the y axis this time. So it's a reflection in, and what's the line? It's a line going across, so it's y equals, and what does y equal? Y equals 1. Look, y equals 1. So reflection in y equals 1. Let's do one last one, and then you can have a go at practicing some yourselves. Let's have a look at this example E. So let's see the distance between these two. 1, 2, 3, 4, 5, 6. So halfway is 3. So 1, 2, 3. So that's the first point on my mirror line. Now the distance between these is probably going to be 6 as well. So that's going to be 1, 2, 3 being halfway because they're rectangle. So my line of reflection is going to be there. So what's my final answer? It's going to be a reflection in, and what's the line? X equals, so it was x equals, and what does x equal? X equals -1. So it's a reflection in x equals -1. Hopefully that's been helpful. Have a go at practicing some questions yourselves now.